Hello, everyone, and welcome to today's webinar. My name is Philip Radukic, and I'm a product manager and a senior consultant here at The Experts, and as such, responsible for the browser-based viewing and associated technologies. But today, I'll be taking a detour to a different topic, and that's how to actually utilize UPV and its components for a cost-effective approach to mainly brownfield projects. And as always, this session will be recorded and we will provide you the link to the recording subsequently by email. At any time during the webinar, feel free to use the chat panel and state your questions, and I will try to answer as many as possible after the session. But now let's have a look at today's agenda. So basically, we're going to have an introduction to the topic, a comparison laser scan meshes versus point clouds, the effort remodeling versus intelligent scans, the time and cost effectiveness of these two in comparison, and advanced features of UPV that basically add on top of the functionality of our digital twin. And we're also going to have a live demo with examples, use cases for intelligent digitalization without remodeling, and also a short glimpse at the performance gain through the browser-based viewing technology. So what are actually the challenges in brownfield projects? So first of all, you need to have some type of model of your assets. But these assets are underlying constant changes. Very often you have missing documentation because parts of the plant or the asset are just so old that part of the documentation has been lost over time. You have scattered information, so different sources for documents, for models, for all types of information we need, and also models modeled in different systems that might not even be compatible with each other. So all in all, it's quite high effort to remodel actually a whole asset or plant, and even doing so, not all parts are being modeled. So what does this mean in detail? First of all, what are the constant changes? What are reasons? Productivity raise, increase in reliability, saving costs, or adapting to market needs similar. All facilities, as I mentioned, sometimes documentation is lost or is available only in paper archives only and similar. Scattered information in various systems, but not really a single point of truth available. And it all requires detailed documentation, preparations, information, drawings for remodeling, and the parts not being modeled, for example, cable trays, HVAC, electrical wiring, most of the time also mobile equipment that might be standing in the way. So what is our solution? First of all, use laser scans as an as-is data source. So that one either exists already or can be done in a short time. And when we're talking about scan to CAD and remodeling, that's a step that's going to be done anyway. Make the laser scan itself intelligent, so you can set bounding boxes, isolate objects, or set points of interest to point out objects from the laser scan itself. Build a single point of truth easily. Well, you can integrate additionally documents, PNIDs, layout plans, etc. We will be coming back to that a bit later. Lower the effort significantly. Well, integrated tools cut down effort to nearly 10%. Well, individually dependent on your plant and documentation. This can be even higher than that, but can also be lower. And all parts are visible. So cable trays, HVAC, electrical wiring, they're all part of the scan, even if not made intelligent. So what are the differences between laser scan versus mesh? A laser scan mesh versus a point cloud. Well, point clouds do have a massive amount of data, are mostly difficult to handle, difficult to measure because it's hard to actually hit the exact point of measurement that you want to choose. You don't have individual objects, and you have quite slow processing. Whereas the UPV meshes are reduced in size by up to 90% and basically lossless because we're combining this point information into real objects with real volumes and surfaces. It's therefore easier to handle, and it's easy to measure and due to the intelligent snap points that our objects and laser scans get. You can even actually convert visual objects into isolated individual physical objects that can be turned on and off independently from the rest of the laser scan. And all in all, UPV technology and algorithms are so powerful that it can handle virtually any size of mesh. So even when we're talking about meshes themselves, there's other products on the market that also can handle meshes, but only to a certain degree before they actually get down on their knees, figuratively speaking. While UPV can basically handle really any size due to the advanced algorithms we're using and the level of detail. So what is the effort comparison between remodeling and intelligence scans? For remodeling, we need to prepare equipment drawings in detail, prepare layout drawings, prepare pipe classes, or at least a dummy pipe class. You need to remodel civil and structures. You need to remodel equipment. You need to remodel the pipelines. And still, not everything can be remodeled, at least not in a reasonable time at a reasonable cost, like HVAC, small bores, electrical, and similar. So what is the effort with making scans intelligent UPV? Well, yes, you still need to collect the documentation for identifying the objects in the scan. So this is a time effort similar to the preparation of documents and drawings and remodeling. And you have to mark the objects in the laser scan. That's it. But even those objects, not made intelligent, they're still visible and identifiable. So it's something you can cope with. So especially when you think that most facilities in Europe are older than 30 years, you can imagine that there's also quite a discrepancy between the as-is state and the documented state. So additionally, you also might have to invest additional effort into measuring out the status on site and similar, which is unnecessary with an intelligent laser scan. So let's look at a real time and cost comparison here. I picked an example project. I myself come from the engineering side of things before I joined CX Experts. So I think this is quite a realistic assessment. An average project with 400 pipelines, 100 equipments, and the according civil structures. So the remodeling effort would be preparing the equipment drawings about 5 man-days. Prepare layout drawings, 5 days. Prepare pipe classes, even if it's only dummy class, taking everything into consideration, probably 10 days. Remodel civil structures, probably 20 days. Remodel equipment in detail, 80 days, and remodel pipelines, 200 days. And I think this is not even a very conservative, but rather an optimistic guess for the time frame. While the effort for intelligence scans in UPV basically takes the following effort: collect documentation for identification, about 10 days. This is approximately equal to the first 2 points on the left side. Then mark the objects in the laser scan. So we don't really make much of a difference between pipelines and equipments here, because it's all part of the object definition in marking. So we can actually approach this in a very easy way and really get done with it fast. So we're talking about 15 days. And then I added another 5 days, which we actually don't have covered on the left side. That's integrate documents intelligently, about 5 days. So what does this mean? We're actually talking about 320 days compared to 30 days. About 10 times faster. And depending on the project, this can be even faster than that. In some very, very some cases might be a bit below this, but not much. So I think that 10 times faster is actually good, an educated guess here. But what additional benefits do we actually get from the UPV model with the scan? Well, first of all, we can enrich laser scans with 3D objects from sketching. We can attach documents and map them to laser scan objects. We can attach PIDs and map them to laser scan objects. We can import data from external sources, databases, ERP systems. I know we have customers connecting to SAP or, for example, Shift Connector from Ashbach, or even Oracle Primavera Unifier. You can use custom attributes on any object to actually individualize the experience and also prepare work packages or define commissioning systems, and so many more. Probably if you've been joining our webinars in the past, you've actually experienced some of the examples and options that UPV gives here. So, but I think the major point is, if it's so easy, well, why are still so many people or so many companies using the remodeling instead of scanning to a CAD model directly, like basically we do? Don't get me wrong, but probably just because they can't. I think as far as I can overview the market, the approach we've chosen is absolutely unprecedented, and I think we're offering a very unique technology here. So this can be only done because of UPV's powerful algorithms on one hand, and the whole system in itself be able to handle this amounts of data easily. So after we've actually talked a lot about it, let's have a quick look into the model itself with a live demo. So let me switch to the model. So here we have an asset that's been completely scanned. From the inside, as you can tell, we have no outside walls here. And we've chosen to individualize this as far as documentation was available. So once we go into the building, you can already see we can move easily inside the building. And whereas in a mere point cloud, you really have millions and millions of points, we have real surfaces here. and also a very photorealistic display where you can even see the writing on the objects, and I'm sure some objects will also be able to actually read the type plate. We can also double click anywhere in the laser scan to actually get into a camera view with panoramic images, and use the slider to switch between the mesh and the panoramic. So let me get out of the panoramic image again and have a look at something different, and that's this filter here. So when in a regular laser scan on point cloud, I could just have a look at this one here. What I can do here is switch to attributes, click on the object, and basically select it. Hold on. Move out a little bit. Picked the wrong one. No. Just a second. Okay, let me switch to the pressure sustainment room. Yes. Okay, back to main hall. And once I click on the object here, you already see there's one document attached here. And when I click on it, I actually get the maintenance instructions for this turbo drain filter. So let's close the settings here. What else can I do? Well, what I did here is I just set a bounding box to identify the object, which leaves the object smart enough to actually connect it. I can see, okay, exists in drawing files, exists in IntelliPID files, exists in PDF2 because we have an attached document. And I could add all types of additional information through Excel, for example. And that's what we did basically as an example here in the pressure sustainment room. When I click, for example, on this valve, which also comes from a laser scan, go to attributes, I see actually a whole load of information added to it. So, for example, actuator, body, general design data. So where does this all come from into a laser scan? Well, basically it comes from Excel and a valve database without us having to remodel the data and enter or import the data into any type of 3D modeling tool. Same goes for the pipeline, which I can click on. And you might have also noticed on the valve as well as on the pipeline, we have one IntelliPID found here. So let's click on that one, and you see it will jump straight to the position in the PNID where this valve is located. And on the other hand, when I click on the pipeline, it says 1 3D objects found. So I can jump back into the model, and it will actually highlight the pipeline here. How does this work? Well, even this PDF has not been done in Smart P9D, but it's basically just a regular PDF P9D that has a readable, or actually searchable PDF as a base, and has been made intelligent and enriched with information, which is also easily done. In this case, we have not chosen to actually just put a bounding box around the objects, but basically isolate these objects themselves. What does this mean? For example, if I want to have a look behind this vessel here, I can actually turn the vessel off individually. Or I could even convert it to a sketching object by creating a sketch. And then just move it around, or even, which doesn't make any sense in this case, but I could even scale it and see, okay, how would a smaller one here look like. This is all things that require remodeling on a high level, or you can just scan it, tag it, and that's it. How this can actually be achieved, it's also quite easy. So when you're talking about time effort, well, how do we actually identify an individual object? Let's get actually back to a sketch here, and let me actually delete the object again, and the original will reappear. So all I have to do is basically, for example, place a cylinder here, scale it to size, bring it into position, and voila. And this is basically saving me the remodeling effort completely. I can now add another box here with the same name. Just give the object a name. Instead of grip on vertical, it would be pressure sustainment unit 01, for example. And that's it. All I have to do now is reprocess the model with a UPVC file generated from the sketch, saying, okay, laser clipping, scan clipping, isolate, and that's all the effort I have to put in here. All additional data can actually be added through, for example, the Excel import plugin or different SDK plugins in the builder. So no worries about actually having to enter data manually, like you have to do in most 3D systems when remodeling. So the use cases here vary. So we're starting from planning a turnaround without having a model, so I can plan, for example, where I could position, hold on, my scaffoldings. Let's actually place a small scaffolding here and say, okay, this is probably too big for this room here, but no, actually it's not. Wonderful, and I need to extend it actually to work on the valves up here on the ceiling and similar. So I can check space requirements. I can also combine it with, for example, Microsoft Project or Oracle Primavera P6 to do real time scheduling and visualize my time schedule to keep track of things. So in addition to saving up to 90% of your time for remodeling, you can actually use the model itself, the final model, for so many more tasks that actually the cost and time saving multiplies this point. Okay, so that's actually been it for the live demo, being a short overview. Actually, I can show you one more detail, and that's what else you can do, and that's add sketching. So this goes a bit in the direction of remodeling, but if you're actually missing parts that are not scanned like the outside of the building, you can also easily use sketching objects to just remodel the surroundings. And for example, for this building, just for visual remodeling, it took about 1.5 days to remodel it. according to pictures we had. I can also give you actual example what the pictures look like, because that's another feature of UPV, that we can project pictures taken from a camera or even a cell phone and overlay them with a model. So by actually moving the slider here, I can easily do a comparison between the model and also the as-is situation of parts that have not been scanned.